What if I told you there's an algorithm that can generate every single valid word and sentence in an entire language? An algorithm so perfect, it's basically flawless. And what if I told you it wasn't written last year or 100 years ago, but was composed over 2.5 millennia ago? Well, buckle up, because we're going to dive into one of the most incredible pieces of ancient code ever created, Panini's language machine. To really get a sense of just how big a deal this was, you have to feel the reverence people had for it. This isn't just some quote, it's an invocation, a prayer almost. It puts Panini right up there with two other giants, calling him the Sutrakara, which means the rule maker. He's the original architect, the one who laid the foundation. This tells you right away we're not just talking about a grammar book, we're talking about a foundational science. Okay, let's frame this in a way that makes sense to us today. Forget your high school grammar class for a minute. I want you to think like a programmer. Your job. Write the source code for an entire living, breathing language, a system that can check, build, and understand every possible phrase flawlessly. Sounds impossible, right? Well, that was the monumental challenge Panini took on. Now, before we get to his mind-blowing solution, you gotta understand the sheer scale of the problem he was staring down. The ambition here is just staggering. Sanskrit isn't a simple language, you know? It's this beautiful, intricate web of nuanced rules for everything. Panini's goal wasn't just to describe it, no way. He wanted to build a system so mathematically perfect that it could account for every single valid expression, with absolutely zero room for bugs or exceptions. A truly perfect map. So, how on earth did he solve this puzzle? Well, he didn't really write a book. He built a machine, a powerful, dynamic engine for language. And here he is, the man himself, Panini, and his masterpiece. Sometime around 500 BCE, he created the Astadhyayi, which literally just means the 8 chapters. And this work would become the definitive authority on the Sanskrit language for literally thousands of years. And get this, he did it all in just under 4,000 rules. 4,000. Now, you might hear that and think, whoa, that's a lot. But stop and think about it. To map out an entire language as sophisticated as Sanskrit, it is an act of absolutely breathtaking efficiency and compression. And this is the part that is so crucial to understand. The Astadhyayi is not a dictionary. It doesn't just list a bunch of words. It's a generative engine. It gives you the raw ingredients, the basic building blocks like verb roots and suffixes, and then it gives you this perfect set of rules. You follow the rules step by step, and you can build any correct word from the ground up, knowing with absolute certainty that it's right. All right, so how does this incredible machine actually work? Let's pop the hood and take a look at the core components. Check this out. This is the very first rule in the entire system. To us, it just looks like a single kind of weird word, right? But it's not. It's an incredibly dense statement. It's basically like declaring a variable in programming. It says the term vritti refers to these specific sounds, a, I, and o. Boom. One rule, one definition, locked in. It's literally code. Each one of these 4,000 rules is called a sutra. And the best way to think about a sutra is as a line of code. It's been ruthlessly optimized. Every single letter, every sound is there for a precise technical reason. There is zero fluff. It's all about maximum efficiency and no ambiguity. But even that wasn't enough for Panini. He ran into another problem. When you're writing rules about sounds, you constantly need to refer to groups of them, like all the vowels or all the nasal consonants. Writing that out every single time is just inefficient. So what was his next stroke of genius? He invented a meta-language, a language to talk about the language. These are called the Shiva Sutras. Now, this isn't just a fancy alphabet. Oh no. It is a brilliantly designed indexing system, a cheat sheet for all the sounds in Sanskrit. By picking the first letter of a group and a special marker letter at the end, he created a shorthand for any set of sounds he wanted. It's a stunningly elegant form of data compression. And the whole system is built with this incredibly logical architecture. The Astadhyayi is organized into 8 chapters that build on each other perfectly, kind of like a well-designed software program. You start with the definitions and technical terms. Then you move on to the building blocks, adding suffixes to verbs and nouns. After that, you deal with all the tiny changes to sounds and accents. And finally, the last chapter puts it all together with rules for the entire sentence. It's a perfect bottom-up design. So, this is all amazing ancient history, but why should we care today?
Well, because the logic that Panini created didn't just stay in the past. It actually echoes in the very foundation of our modern world.
I mean, just look at these parallels. It's uncanny. Panini's sutras, that's basically what we now call a formal grammar. It's the theoretical engine behind modern programming languages. His Shiva Sutras, that's a masterclass in abstraction and data compression, two of the most fundamental ideas in all of software engineering. And the whole generative process, that is exactly what a computer compiler does. It takes rules and source code and builds a working program. He was, in a very real way, a computer scientist 2,500 years ahead of his time. And that's why this isn't just a historical curiosity. Many top linguists and computer scientists consider the Astadhyayi to be one of the single greatest intellectual achievements in all of human history. When it was discovered by Europeans in the 19th century, it helped spark the entire modern science of linguistics. It's a system that's complete, consistent, and totally non-redundant. Just unparalleled genius. Which brings us to a final, really fascinating question. As we work to build artificial intelligence that can truly understand and generate human language, we're still grappling with the exact same problems of ambiguity and complexity that Panini solved. So you have to wonder, could the elegant, logical architecture of his ancient language machine hold a key to the next great leap forward in AI? Something to think about.